All right, the first thing you're going to do, obviously read the question. So it says find v of t, which means we need to have our final answer in time domain. So right now our circuit is in time domain. So the first thing we need to do is convert it to phasor domain. And what we mean by that is we're going to redraw this circuit in AC steady state analysis. So let's just write out some characteristics of our circuit. So we know that the angular frequency is going to be 1. We know that the phase angle is going to be, for our source, the phase angle is going to be 0 degrees, and then we know that the amplitude is going to be 10. Okay, and then if you forgot why, for a phasor, the formula is the amplitude times cosine omega t plus phi, where x amplitude is the amplitude of the sinusoidal wave, omega w, or w is it's the angular frequency, and then phi, which is the phase angle for our phasor. Okay, so then as you can see, the phase angle is going to be 0, amplitude is 10. Okay, so let's also calculate the impedance values for all of our circuit, or for all of the elements in the circuit, because that's how we put our circuit in AC steady state, right? ZR is 1 ohm, ZC is 1 over J omega C. Plug in all those values, you're going to get minus J omega, or minus J ohms. And then ZL is going to be J omega L. Plug in all those values, you're just going to be left with J ohms. Okay. Now we got to redraw our circuit. So all right. It might not be super obvious, and if it's not, these two branches right here are actually shared in parallel. The one I'm circling in blue, and then also the one I'm circling in red. The ones in red, if I combine them, it's just going to be 1 plus J omega, and we can combine them because they're connected in series. After you combine them in series, you're going to be left with one element, and that element is going to be connected to the blue circle in parallel. And then if you're wondering why they're in parallel, it's because they share those two green nodes. So why does all this matter? It's because elements in parallel share the same voltage drop. So what I can do is I can actually combine both of these sides and have one large circuit all in series. So let's do that. Okay, so I'm just going to denote this as Z on the right hand side, and that's going to be minus J, 1 plus J, 1 plus J, plus minus J. Okay, so that whole bottom, or sorry, the denominator is going to evaluate to 0, obviously, right? And then on the top hand side, we're going to get 1 minus J. So that whole right hand side is 1 minus J. Yeah, so let's redraw our circuit one more time. Shoot, whoops. All right. Now, depending on like what level of circuit analysis you're at right now, you might see either or your teacher or your instructor, whoever, they might be putting a box. All that really means is it's a way to denote this whole piece right here. So because it's a positive value right here, we know that it's a resistor, And then since this is a minus J, we know that it's a capacitor because capacitors are the only ones that will ever have minus J, right? Because 1 over J is just going to be minus J. And then that is a property of the square root of -1. Little refresher. Okay. So now we're at the last step. So we can either do a voltage division rule, which might be quicker, or we can do whatchamacallit, or we can do a KVL. If you get confused, or you can only do VDR when the polarity is faces this certain way, right? Because V of t is going to be consuming energy from this source. So if that doesn't, or if that confuses you a little bit, one surehand way once you get to like this last circuit is going to be just do KVL if this confuses you. Right, where this whole thing is 1 minus J. We'll draw it as a box for now, but really what we have inside of here is a resistor and some capacitor, but I'll just draw it as a box, so just humor me. Okay. I'm gonna define our KVL current as clockwise. Okay, so let's do the KVL. Yeah, the KVL is an extra step, but let's just do it. Why not? Minus 10 angle 0 plus 1 times I plus 1 minus J times I equals 0. Shit, my writing stinks. Okay. And then what we're left with is, let's see, what is this? 2 minus J equals 10, or sorry, I equals 10 over 2 minus J. Yeah, that's correct. Okay. And then last step, all we need to do to solve for V of t is use our phasor equation. So we just found I, and we know Z, right? It's 1 minus J. So here's I, 10 over 2 minus J times I, and then and then Z, which is going to be 1 minus J. And then that's going to give you, where is it? I'm too lazy. Yeah, so it's going to give you 6.32 cosine. Oh, wait. 6.32 angle minus 18.43. But this is phasor form. Like when you see a capital V, and usually it'll be in bold, it's in phasor form. Because this one is in lowercase, and it also says with respect to time right there. Right, time says in respect to time. We know that our final answer has to be in the time domain. So remember, this is the phasor domain. So we're almost done. All we need to do is convert this. That's super easy. So we just plug it back into this equation right here. Right. Or shoot, this should probably say time. 6.32 cosine t minus 18.43. All right, and then that is your final that is the final answer. All right, if you guys found this video helpful, leave a dislike, unsubscribe, all that helpful stuff.